All right, let's take a look at question number 7. We're to find the limit as x approaches 0 from the right of the square root of 5 plus x plus square root of 5 over x. Now, if you notice, this is a directional limit, and in most cases, directional limits normally exist, except you are oscillating as you approach the limiting value. All right, so we don't have any sine or cosine, any trig function here, which basically could result in oscillation. So we're confident that we can find this limit just by direct substitution. Now, most students will look at this and think about rationalizing. That's fine, you can do that. But since this is a directional limit, there's no need to do that, okay? But what I'm going to do, I'm going to show you two ways of doing it. I'm going to do it the quick way first, and then I'll show you that rationalization is fine too, okay? So just by direct substitution, if I plug in 0 from the right into this expression, I'm going to get the square root of 5 plus 0 from the right plus the square root of 5 over 0 from the right. And then that basically becomes the square root of 5 from the right plus the square root of 5 over 0 from the right. And that's equal to 2. If you combine these two together, it's 2 root square root of 5 from the right over 0 from the right. Okay, I will know what 0 from the right basically is. 0 from the right is the same thing as 1 over infinity. So we have 2 times the square root of 5 from the right over 1 over infinity. Okay, and then we'll multiply 2 root 5 from the right with infinity. We'll have 2 root 5 from the right times infinity, and your final answer is simply infinity. Okay, you can see that we're able to evaluate this limit without rationalization of the numerator. Okay, now let me go ahead and show you by rationalizing the numerator that we're going to get um, the same result. So this method right here, we can call it direct substitution. And then here we're going to use rationalization. Okay, so if we rationalize the numerator, we're looking for the limit as x approaches 0 from the right of the square root of 5 plus x plus the square root of 5 divided by x. So what I'm going to do here is multiply the numerator and the denominator by the conjugate of this numerator expression. Okay, so all I simply do is I invert the sign, root 5 plus x minus root 5, the sign between the two radical quantities. Okay, multiply the numerator and the denominator by that. So what I'm doing in the numerator is I'm trying to create a difference of squares. Because when I expand the difference of squares, I'll end up with the first term square, which gets rid of the square root, and the second term square, which gets rid of the square root also. Okay, so we're going to have the limit as x approaches 0 from the right. If you expand the numerator, you're going to end up with root 5 plus x square plus, actually it's minus root 5 square. In the numerator, you might wonder why. Well, if you FOIL it out, imagine if you have a plus b, right, times a minus b. If you expand this, you know you have a square plus ab minus ab cancels out minus b square. Okay, this is a difference of squares formula. That's what I applied here. So we have a plus b, and then a minus b, and then when you expand it, you end up with a squared minus b squared. Okay, so that's the story for the numerator. In the denominator, we're going to have x times the square root of 5 plus x minus the square root of 5. Okay, let's go ahead and simplify it a little bit more. In the numerator, we're going to have, let's see what we'll have in the numerator. Limit as x approaches 0 from the right. The square and the square roots are inverse operations. They cancel out. Same story here. So we have 5 plus x minus 5 divided by what we have in the denominator, which is x times the square root of 5 plus x minus 5, minus root 5. Now I'm not going to distribute this x. My hope is that this x gets cancelled out somehow, okay? So this becomes a limit as x approaches 0 from the right. Now this 5 and that 5 cancels out. So we have x over x times the square root of 5 plus x minus root 5. Now the x's divide out. So this becomes a limit as x approaches 0 from the right of 1 over square root of 5 plus x minus square root of 5. Now, had it been this for a double-sided limit, it's not going to work because you're going to approach two distinct values. But since this is a one-sided limit, you're going to see that it's going to work out, all right? So let's go ahead and finish this up. If I plug in 0 from the right, I'm going to have 1 over 1 over the square root of 5 plus 0 from the right minus the square root of 5, okay? So that becomes 1 over the square root of 5 from the right. 5 plus 0 from the right is 5 from the right minus the square root of 5, and that gives us 1 over the square root of 0 from the right. If you square root that, you still end up with square root of 0 from the right. Think about 0 from the right as a really, really small number, a number that's infinitely close to 0 from the right. Okay, so if you take the square root of that, you're still going to be really, really close to 0 from the right. What is 1 over 0 from the right? That's the same thing as infinity. Okay, so we can clearly see that our answer is infinity. That's the same answer we got over here, infinity, infinity. This is just a different way of doing it. All right, so that's that. All right, so you can feel free to advance to the next question and click on next to go to number 8, or you can go back to the main test menu. Don't forget to subscribe for updates to other cool tutorials such as this.